Hello and welcome back to Calculus 2, section 8.5 on partial fraction decomposition. I hope I have all the letters in order. So let's go and see the algebra part first, and then we will work on full problems. Some of you might have learned partial fraction decomposition in pre-calculus because it's in one of the optional sections. The others never seen it before, so we'll just have to go through it like no one ever seen it before, including me. So we are going to start with two rational functions. They can be linear, they don't have to be, but let's use linear. So 3 over x minus 2 plus 2 over x plus, let's say, 5. Actually, that is going to be your target. But let's first start from understanding that we can use algebra, common denominators here, to add these two into a single rational function. So if I multiply this side by x plus 5 and this side by x minus 2, we would have 3x plus 15 plus 2x minus 4 divided by x minus 2x plus 5 in denominator, which would simplify into 5x plus 11 divided by x minus 2x plus 5. So this would be the standard algebra problem that you would see in elementary algebra or whatever, algebra 1, whatever you want to call it. And I'm going to put the arrow, when you do the problem this way, I'm going to call it algebra. Now, if you start here and you go there, it's going to be called partial fraction decomposition. And I hope that the name makes sense, because you are decomposing one fraction into multiple fractions, in this case 2, right? To obtain, right, separate fractions like you have over there. So our goal is to learn to go back. So what do we do when you are given 5x plus 11 divided by x minus 2, x plus 5? How do you split this up? So the first thing that you have to memorize are the 4 setup cases. And then there is a procedure that you grind through to solve this. So I'm going to remove this, write those 4 cases. So the first case is going to be if you have a linear term in the denominator. So I'm going to just say blah divided by x minus c. I put blah because you have something up there. All right, I don't care what it is. We worry about the denominator. So if the denominator is a linear term, it could just be x, could be x minus 2, x plus 6. So if you have a linear term in the denominator, your setup is going to be a over x minus c. If you have a repeated linear term, which means it's squared, your setup is a over x minus c plus b over x minus c squared. Number 3, if you have blah over ax squared plus bx plus c, which is a quadratic that you cannot factor any further, is going to be ax plus b over ax squared plus bx plus c. Make sure that capital A and lowercase a are not the same number. They're not the same constant. And finally, number 4 is the repeated quadratic that you can't factor any further. And that one is going to give you ax plus b divided by ax squared plus bx plus c plus cx plus d ax squared plus bx plus c, everything squared. I just noticed that I don't need these parentheses here. Yeah, there we go. I hope you see the pattern. You can pick up few patterns to memorize these. And I did tell you last class that you are supposed to start this section if you're going to differential equations, because your inverse Laplace transforms are going to use this. So if you're going to diffq, you are learning these now for this section and the diffq, right, inverse Laplace. So don't play with fire, right? What do we see? If you have a linear in denominator, the numerators are constants. If you have quadratic in denominator, your numerators are linear. So you see that like a step down in the power just by 1. So linear, constants, quadratics, linears. Again, capital A and B are not the same as a lowercase a and b. Those are going to be different numbers. So 4 cases, which means that factoring skills are going to be necessary, right? And then completing the square might make an appearance again because that's your favorite, right? You can encounter multiple setups within the same problem, which means that you will be combining these. You might have, let's say, x minus 2 squared and this one, in which case you will have a, b, c, d, right? So those capital A, B, C, and so on, if they're already used up for the previous, right, setup, well, we'll see that, like, you keep using the next letter available in the alphabet. And just having these, right, so I'm going to write them on the board so we can actually work out examples and so on. So if we have, I'm just going to copy the whole thing, so you can look up and immediately know what to use. I'm still here. Don't magic. Anyway, so there they are. Now you have them on the board. You have the blue for linear terms and the black for quadratic terms in denominator. again, only the ones you can't factor would be quadratic. X squared plus 1. X squared plus 1 cannot be factored any further. X squared minus 1 can. What's x squared minus 1 factored? X plus 1, x minus 1, so those will be two of these guys, right? So if you can factor a quadratic, then those factors that you get, which are linear, will fall in the number 1. If you run into something you cannot factor any further, like x squared plus 1, then in that case, you are going to use number 3. So let's work out the procedure to do the partial fraction decomposition on the problem that we already know, right? And work the whole procedure to get the answer that we already know. So 5x plus 11 divided by x minus 2x plus 5. So what do I have? When you take a look at these factors, I have two linear terms. Therefore, I am setting up a over x minus 2 plus b over x plus 5. So you already see that it's getting into the form of your, right, of what you need. Okay, so now the only thing I can do here is cross multiply to find common denominator. So when I cross multiply, get x minus 2x plus 5, you see that in the numerator, I get ax plus 5a plus bx minus 2b. Are we all agreeing on that? Cross multiply to come up with a common denominator. And now you compare the problem with what you have. Denominators are the same, so that's not interesting. What's interesting is, let me do this. Compare. There we go. So if we compare these, denominators are not interesting. We get 5x plus 11 is equal to ax plus 5a plus bx minus 2b or not to be. All right. We see x on the left and we see x on the right. We see constants on the left and constants on the right. So that's an x term, that's an x term, that's an x term. And in blue, that's a constant, that's a constant, that's a constant. Bueno? So, in red, 5x is equal to ax plus bx. You get rid of these x's. A plus b is equal to 5. Blue equation says that 11 is equal to 5a minus 2b. From where? 5a minus 2b is equal to 11. And there's your system. System of two equations, two unknowns. And now you have to solve that system. It will give you capital A, capital B, which you will plug in where you have to plug in, and problem is done. Now, use whatever method you like the best, right? Guess and check method, substitution, elimination, essential oils, whatever works, just get A and B out of it. I'm going to multiply top equation by 2, which will kill B's. So I have 2A plus 2B is equal to 10. And then I have 5A minus 2B equals to 11. When I add two equations, I get 7A equals 21, A equals 3, And if a is equal to 3, I have 3 plus b is 5. B is equal to 2. So I have the a and b. I go here and I say a was over x minus 2. So 3 over x minus 2, because that's your capital A. And then plus b was 2 over x plus 5. You go up all the way, and haha, that's exactly what we were aiming for. Now, clearly, in the problem, you are going to get, this thing, and then you don't know what you're shooting into, right? So just work out the procedure. So that's the full procedure. You use the setup, then you use algebra to combine them all, and then you equate the numerators, and then put x's with x's, x squares with x squares, constants with constants. You might have number of equations. And then you will solve the system, and then just carefully plug in where a and b go. So let's do another 7,000 examples and then go home. What is the type of the problem that you have in this section? Well, something like this. Integral of 21x squared divided by x cubed minus x squared minus 12x dx. Right? Someone just said integrate. I can set up the scene, right? You're hired, you go to the work, right? And then the boss comes to your cubicle and says, integrate this. Because that's the work. If you don't, well, you lose the bones. How about that? So, the first order of business is to look at the exponents. If the exponents are the same, or the numerator has the higher exponent, you have to use long division. Partial fraction decomposition works only if the denominator has the higher power. You should write that in blood. Even though it's not in this example, eventually you're going to run into example, both have x squared, both have x cubed. You have to do long division first. So, if the exponent in the numerator is bigger or the same as the denominator, you must long divide. Alternatively, you can write partial fraction decomposition works only if the exponent on the denominator is bigger. That's it. So now we have the 3 in the denominator, we have 2 in the numerator, we're all good to go. No long division here. All right, great. So this is going to be set up, well, I have to factor, right? So that's 21x squared. I kick out x. When I kick out x, what's left is x squared minus x minus 12. And now that factors, right? Anyone? Excellent. -4 and +3. Perfect. So your step number 1 is to factor denominator as far as you can. Clearly, if you get x squared plus 1, can't be factored anymore. Well, you have to deal with it. So you factor denominator as far as you can, and then you say, okay, let me see what I have. I have 3 linear terms, so this is going to be 3 number ones. 3 number ones. What do I have? For the setup, well, we're just doing the algebra part now, so no more integrals. I'm doing the 21x squared over x cubed minus x squared minus 12x is equal to a over x. Because x is a linear, you can think of it as x plus 0. Still linear, right? Falls under number 1. X minus 4, also linear, so plus b over x minus 4. And the last one is c over x plus 3 because it's also linear. Well, great. Now I have 3 variables. 3 variables will mean 3 equations for the system later on. The number of variables in a setup equals the size of the system you have to solve later on. So, yes?
Do you have to about one of the x's before you go into decomposition?
You can.
21x over x minus 4.
You can. And now you can't. Right?
All right.
Just thinking if anything would explode if I, in this particular example, if I do that. Nope. Apart from not being defined in that value, everything else should be okay. All right, let's make it easier then. Let's kill it. Fine. So, kill that. Well, now that we are in this business, kick 21 outside. So now you really made it simpler. And now these are going to be A and B. Now I got to move everything. There we go. All right. So now I have to kill the square, kill 21, change this into x minus 4x plus, there we go. Excellent. Cross multiply, x minus 4x plus 3, and then we have ax plus 3a plus bx minus 4x, no, 4b, I lied, 4b, there we go. And this is where we compare the two. So ax plus 3a plus bx minus 4b is equal to x, and if it's going to make you happy, you can put x plus 0. So now you have the x terms, and you have the constant terms. Red equation is a plus b equals to 1, right? When you get rid of the x's, a plus b equals 1, which is a coefficient of x. And then the blue equation, 3a minus 4b is equal to 0. Multiply top equation, say, by 4 to kill the b's, and then add them. It's going to be 7a is equal to 4. From where a is equal to 4 over 7. And if a is 4 over 7, then b better be 3 over 7, because they need to add into 7 over 7, which is 1. For the red equation. You can quickly check with the blue equation where 12 over 7 minus 12 over 7 is 0, which is good. So now we have our A and B. So now the integral is A, which is 4 over 7 divided by x minus 4 plus 3 over 7 divided by, it's terrible to write these fractions this way because they look like 417 and 317. So 4 over 7 and 3 over 7, and then we have x plus 3 dx. You can separate this into separate integrals at 4/7 integral of dx over x minus 4 plus 3 over 7 integral of dx over x plus 3. And what do we know about these integrals? I told you you're going to be sick of them because every problem is going to have it now. Yes. 4 over 7 ln absolute x minus 4 plus 3 over 7 ln absolute x plus 3 plus c. Oh, I forgot the 21. Yeah, we should just go home. I think we're done. At least I am. There's a 21 in front. And that will kill the 7s. Yeah, it will kill the 7s. So that's 3 times, so it's 12 ln x minus 4 plus 9 ln of x plus 3 plus c. When you cancel 21 with these 7s, and that would leave you with a 3, so 3 times 4 is 12, and 3 times 3 is 9. Cool, huh? Of course, math. Let's do another one. I did the first one correct, right? So now I'm in the 50-50. Okay. Someone should keep the track. See if we can find one that we're going to regret. All right. Always check if the long division is necessary, then do the rest. So we have 16x squared divided by x minus 6, x plus 2 squared. They're so nice, they factor it for us. See? They're amazing. Since everything is factored, you should immediately see what setups do we use. Number one and two, very good. Numbers 1 and 2. So number 1 goes for the first one, and number 2 will go for the second one. Because you have a repeated linear. All right, so now you're going to use A for the first one, and then B and C for the second one. And we are going to end up with let's you can kick the 16 out probably. Okay.
And then, so you just have to do x plus 2 squared minus x plus 6. That has to be above. Because this one already has x plus 6, so like, the company left, you can x plus 2 squared. Let's take the bottom shape.
Okay, let's take a look at it together. Kick 16 out. Have the x squared divided. No, let's just make the setup. So kick 16 outside, and we are going to have a over x minus 6 plus b over x plus 2 plus c over x plus 2 everything squared dx. There we go. So now we have a over x minus 6 plus b over x plus 2 plus c over x plus 2 squared. And that needs to be equal to x squared over x minus 6 x plus 2 squared. So we played the game of what's missing, right? The last one is just x minus 6. This one is missing x minus 6 and x plus 2. And the first one is missing x plus 2 squared. So now you have to multiply all of these, and you can ignore the denominators. So it's that when you FOIL x plus 2 squared, we have a times, let's just write it, squared plus b times x minus 6x plus 2 plus c times x minus 6 equals to x squared plus 0x plus 0 if you want to, match them term by term. So now you need to FOIL all of this and multiply by a. That's x squared times a plus 4ax plus 4a plus bx squared minus 4bx minus 12b plus cx minus 6c equals to x squared plus 0x plus 0. Now, red equation, you have your squares. So what you learn from there is that, here, red, is going to be a plus b equals to 1. Then I have my blue equation, which are all the single x terms. And that's going to be, for the blue equation, 4a minus 4b plus c equal to 0. So we don't write x's, we just write the coefficients. And finally, in, let's say, green, we have constant terms. And that's going to be 4a minus 12b minus 6c is equal to 0. And from this point on, good luck. Now, to solve the system, make sure that you are dividing to reduce numbers everywhere you can. So you can definitely divide the green equation on the bottom by 2 to reduce numbers. But in this particular case, that would not help because we already have 4a and 4a. So if I multiply the top equation by -4, I can kill a's in all of the equations, right? So it's a very good skill to cancel everything you can down to the lowest possible value. But then in this particular case, these a's lined up nicely with a 4a and a 4a. So let's just use it. So now the top equation becomes -4a minus 4b equals -4. By the way, this -4 is usually where your grade withers, because you forget to multiply that side for whatever reason, and then obviously that mistake will carry through. I have 4a minus 4b plus c equals 0, and another 4a minus 12b now minus 6c equals no copying 0. And now I will add the first two, and I will add first and the third equation. So that's going to give me -8b plus c equals to -4 when I add first two equations. And when I add first and the third equation, a is canceled. -16b minus 6c is equal to 0. No, lies, -4. All right, so now there's way too many negative signs everywhere, right? But such is life. We multiply this one with -2, and we can kill b's. Good. So when I multiply by negative, I have a 16b minus 2c equals to +8, and then a -16b minus 6c equals to -4. Just copy it, and when I add them, b's cancel. I have -8c equals to 4, c equals -1/2. And now I bring that one to calculate b, and then eventually calculate a. So from, let's say, this equation here, if I divide, no, I just plug in because -1/2 will kill the 2. Perfect. So 16b minus 2 times -1/2 is equal to 8. This is going to be 16b plus 1 equals to 8. 16b equals to 7. B equals to 7 over 16. And then you have a plus b equals 1. And b is 7 over 16, so a better be 9 over 16, because 9 plus 7 is 16. 16 divided by 16 is 1. So there they are. This time I'm not going to forget the constant, which is 16. So now I have 16 integral, and now I have my a, which is 9 over 16. That's not a 6, oh, here, 16. Fixed. So you gotta fix these quick. X minus 6, so dx over x minus 6. Nah, just put 1, put everything in the same. Plus b, which is 7 over 16, 1 over, oh wait, there was a b, yeah, x plus 2, plus a c, so minus 1/2. That is sneeze. X plus 2 squared, and now dx. Perfect. Multiply through by 16, and we have the integral of 9 over x minus 6 plus 7 over x plus 2 minus 8 over x plus 2 squared dx. The first one is what when you integrate? 9 ln of absolute x minus 6, plus second one is 7 ln of x plus 2. And now what? Very good. So u sub u equals x plus 2, du equals dx. So we still have to work this one out, which is negative 8 integral of du over u squared. So that one we have to do, right? So that's going to be integral of u to the minus 2 du, which is u to the minus 1 over negative 1, which is negative 1 over u. So the whole problem is 9 ln of x minus 6 plus 7 ln of x plus 2. And now minus, and minus from the problem gives you a plus 8 over, and u is x plus 2 plus c. Woohoo! A little bit quiet tonight. I guess it's tired. It's not speechless, I hope. Yes? Sure. How far are we going? Are we going into algebra? Are we going into... If he points out a mistake right now, I mean... It's good. Yeah. It's what he aims for, to make me cry now. After a whole month and a half of class, it's like, okay.
go back to the first lecture so I can tell you about the signal?
Lock the doors. Integral 20x divided by x minus 1. It's a linear factor. X squared plus 4x plus 5 dx. What happened? The answer is 3? Okay, fine, whatever. This is the best when 3 students get all different results. Give one problem on a test, I get 28 different solutions. One might be right in that case, or none. Do you honestly think I can make this any better?
We should just cancel it out.
There's nothing. And I told you, right? Partial fraction decomposition for inverse Laplace transforms. There's going to be a part 2 of this thing if you take DiffyQ next semester. So.
Yeah, I'm gonna get there eventually. Actually, next year. Builds character. I don't know, it's not safe. Okay, so let me do the same thing. Right, so same pattern.
In English class.
one of these colors. I use colors because I have them, because I need to see. Maybe 0 x squared.
Yes.
I invest 2 calories. I can't see the equation. I come with that.
Oh, yeah, we don't use x. That is 10 to the cable instead. How much is that? I'm the good side.
So, 12 half.
This is one of these sections where we need to warm up the wrist before you start. So these exercises, you grab your right and you turn in the largest circle you can. This section is amazing for killing time and developing carpal tunnel. This section is awesome for both of those, right? And then the next one is you put the hand like this with the thumb down, right? And you grab and you gently, don't break the wrist, right? Pull this way down to stretch, everything. And then you are ready to do the homework. Do not attempt homework prior to these. So what should I do here? I guess add these two to kill C.
Oh, wait, he's right out there. Sorry.
Second, I know you're excited. I mean, it's awesome. It's math, so A plus B equals 0. 9A minus B equals 1. So now we add these puppies. Get 10A equals 1. B equals 1 over 10. Thank you. B is negative 1 over 10 because they need to add to 0. And C, so 5 times 1 over 10 is equal to C. They cancel. And you know what? I'm not going to cancel. I'm just going to leave it as 5 over 10 because then all my constants are over 10 and I can pull that out. So C is 5 over 10. So now the integral, we kicked 20 out. So kick 20 out. The first one is A, which is 1 over 10, divided by x minus 1, plus B is negative 1 over 10 x plus 5 over 10. And then we have the x squared plus 4x plus 5. No. Plus 4x plus 5. And then dx. So now when I factor out 1 over 10, that's just going to be a 2 now. And we have 1 over x minus 1 plus negative x plus 5 divided by x squared plus 4x plus 5, everything dx. Great. So that's 2 separate integrals. The first integral is clearly 2 ln x minus 1. And then we have plus 2 integral of, let's go 5 minus x divided by x squared plus 4x plus 5, dx. What should we do for the second integral? Well, we can't factor it, so we can't do partial fraction, right? It's unfactorable quadratic, which is why we use number 3 for it, right? We can't do the long division because the top power is 1, the bottom one is 2, right? So the power in the denominator is... then what? If you separate into... That's a great suggestion, because when you have plus and minus in the numerator, that immediately means that you can separate into 2 integrals, and then you would have 5 divided by quadratic and the x divided by quadratic, and we are still doomed. Integration by parts. So how would you split it for integration by parts? Yeah, when in doubt, integrate by parts, right? That's the saying. That was a good thing you remembered. Google it. Okay, that's also one of the. Try Bing. Man, you can Bing it. Sounds weird, Bing it. So I want to start using that from now on. No. Complete the square. Most likely we can use trigonometric substitution to solve this one. I know, right? How about we complete the square, see where we get with that. So, completing the square in orange as the tradition, right, in this class. Wait, did someone in this class ask for rainbow color? No, there was a different class that asked for rainbow color. Oh, this class. Okay, rainbow colors in this case. X squared plus 4x plus 5. Look at that. Amazing. Can you see it? Yeah, you can, right? So the plus 5, we are going to break into plus 4 plus 1, actually. So plus 4 plus 1, because these 3 are going to give you x plus 2, everything squared, and then you still have plus 1. Perfect. There we go. End of rainbow. Now we have 2 ln x minus 1, that's the first part, plus 2 times the integral of 5 minus x divided by x plus 2 squared plus 1 dx. We have our triangle. Well, actually, hold on. I have to split this first. Gotta split them first. So 2 ln x minus 1 plus 2 times the integral of 5 divided by x plus 2 squared plus 1 minus 2 integral x over x plus 2 squared plus 1 dx. There we go. Beautiful. What's this one? That's a basic one. Not ln. Inverse tangent. Thank you. It is of the form 1 over u squared plus a squared. You're using u sub to work that one into inverse tangent. So now we are at the situation 2 ln x minus 1 plus, this is going to be 10 inverse tangent of x plus 2. And now we have minus 2 times the integral of x over x plus 2 squared plus 1 dx. This is where the trig sub is. So here, happy. Trig sub. So for the trig sub, we have our triangle. It's what we did 2 days ago. We have a plus, which means we have two legs. So x plus 2 and the 1. And this one is the square root of x plus 2 squared plus 1 squared, which is 1. We are going to create the red and the blue pair of equations. Red one is the tangent theta, which is x plus 2 over 1. X plus 2 is equal to tangent theta, and the dx immediately is secant squared theta d theta. The blue set of equations is going to be cosine theta, which is 1 divided by the square root. Square root is 1 over cosine theta. Square root equals secant theta. Now we are not happy with the square root, because square root of x plus 2 squared plus 1 equal to secant theta. We don't need the root, so we have to kill the root by squaring it, which gives us secant squared on the other side. So my integral now becomes -2 integral of, instead of x, I have tangent theta minus 2 divided by what? Secant squared theta, everything d theta. Great. So now that further breaks down, because now we have another subtraction into -2 integral tangent theta over secant squared theta d theta plus 4 integrals of d theta over secant squared theta. Say no more. Yes, the dx needs to be replaced by secant squared d theta, which changes everything. Because now secant squared will kill the secant squared, and that makes this problem much easier to deal with. Yeah, I was testing you, and I just wanted to see if anyone's paying attention. Very good, very good. So -2 integral of tangent. Yes, very good. It's a log. ln secant theta plus tangent theta. Very good. And then integral of -2 is, right, you have the other one, so plus 4 theta. And now we have to go back into x's. So -2 ln secant is 1 over cosine. So the sides are hypotenuse over 1, which is the square root of x plus 2 squared plus 1. Plus the tangent is just x plus 2. Plus 4, and theta can be inverse of anything, so tangent inverse of x plus 2 plus c. So we are finally ready to write the answer.
Actually, the tangent interval should be just secant.
No.
Log of secant. Yeah, it's here. The secant one is secant of last time.
Log of integral of tangent.
It's the log of.
Integral of tangent is sine divided by cosine. And then you do the u sub. U equals cosine theta. Du is negative sine theta d theta. So you have the integral of du over u with the minus in front. And it's just ln u with the yes. Okay, you win. That's fixed. So now we don't need this part. Oh, there's a plus c over here. That's a minus 1 right there. Okay. Holy nightmare. Yeah, that's why I said lock the doors. 2 ln absolute x minus 1 plus 10 tangent inverse of x plus 2. And now this is the other one. Okay, so now this solution minus 2 ln of the square root of x plus 2 squared plus 1. We don't need the absolute values because square root will always give the positive value, so we can just kill the absolutes here. Plus 4 tangent inverse. Oh, that's the same. So that's just instead of 10, 14. Ha. So that's a 14 right there. And we have plus c. See, it simplifies nicely.
That's question 1.
Which is why this is the last problem you do on the exam. Now, obviously, your problem on the test will have less variables and less flaws, but you know what happens in the homework. Massacre. Now, you don't get to avoid these guys in differential equations, so, yeah. Yes?
Is this test going to have 10 questions, or are you going to surprise us with 12?
Surprise you with
Because
12.
I had last test, you said there would be 10 questions.
Yes, I lied.
Yeah, exactly. So,
It was, yeah, I don't know, we'll see. Maybe 8, I don't know, because that's gonna take 30 minutes, right?
yeah.
That's the whole test.
So it's one question, that's it, that's the
That
test.
covered multiple chapters.
Yeah, I ended at question 11 overnight, so I have to, yeah, I did lie. And the replacement question you use to replace them, so you don't get to count. So it was 10. Oh, I know. I ended at 1.
That one was super.
No, I had students that actually worked it out. I had like little tick marks. Some people did it.
I did it on my finger.
If you cut each one in half, it would be weird. It's like you have 10 in the fence in each one. Wow.
I didn't have to pass it. Like,
You can text. Woo.
I was pretty lost at the point where we had to put the trees up with like,
All right.
still like 2 pages.
Like this is just work. This is just like this. Because I'm like, all right, good.
I'm looking at a problem. I have no clue how to do it, so maybe we should do that one. Or
The evil one. Is this the evil one? Or is that?
nah, there's no. Okay, let's do this one, and then I'll think about the other one. It's just pure fun. X to the 4 plus 1. X cubed plus 9x dx. So what's fun about this?
Nothing.
Yes. Well, then just you're free to leave.
I don't even remember when I learned this.
intermediate algebra.
Like, I don't remember how long
So
ago
that
that was.
how long? Calc 1, pre-calc 2, pre-calc 1, and then. Okay? So it's been 2 years.
No. That's like high school.
Long division of
I
polynomial.
think I learned that like in freshman year, maybe.
But I think it's
Pops up.
polynomial long division. I don't think
Long
it's
division.
math work.
Pops up.
I feel like I glossed over that one. It was definitely mentioned.
I did a little bit of polynomial long division. Like, it's not bad.
After today.
I don't remember.
I don't remember the other, but I just remember it's not.
Oh.
Yes, exactly.
We have that teacher.
Feel good content without this.
It would be great.
I'm just saying, you can see how this is. You don't want more of the rings, you get paid for just add it right here.
There is actually pillows.
That's half the semester, that's the third of the the science building, is great.
Yeah, that's the clear up.
It's already Thursday. All right, so that was, I guess, enough of I don't know how to long divide. So let's do the long division so you can do the rest of the problem. So x cubed plus 9x divided into x to the 4th. That's bad. You need all the placeholders. So x cubed plus 0x squared plus 9x divided into x to the 4th plus 0x cubed plus 0x squared plus 0x plus 1. There we go. Placed in all of the placeholders so you don't have to worry about adding different powers, right? So now x cubed goes into x 4th x times, and then you multiply back, you get x to the 4th plus 0x cubed plus 9x squared. And then you subtract. So that kills the x to the 4th. 3's are done as well. You have 9x squared plus 1. And now x cubed doesn't go into this, so you're done. So it's plus 9x squared plus 1 divided by x cubed plus 9x. And this is now your new problem. It's x plus 9x squared negative 9x. Okay, fine, you win. I was testing you. Negative 9x squared plus 1 divided by x cubed plus 9x dx. So now you have two separate integrals to worry about. The first integral is x dx. Good luck with that. Plus the second integral is 1 minus 9x squared divided by, you kick out x, you have x squared plus 9. Yep. X squared plus 9 dx. So the first integral is easy. Second integral, partial fraction decomposition, right? So for the second integral over here, we have a setup of a over x plus bx plus c over x squared plus 9, because that's a quadratic that I can't break down. So now we are going to cross multiply this. We have bx squared plus cx plus ax squared plus 9a divided by x squared plus 9. So now I have the x squared equation, and that's going to be a plus b equals to negative 9. Then we have a x equation, which in my case here is just c equals 0 because there is no x. And then the green equation, which is our constant, which was 9a, is equal to positive 1. So c equals 0 already solved. From the green equation, we have that a is 1 over 9. Bring that back into the problem above in the red line. So 1 over 9 plus b equals to negative 9. So what's b? 81. And the 1 is 82. Negative 82 over 9. Great. So now what do I have? All these integrals. I have integral x dx plus the integral of 1 over 9 over x plus, and the second one is bx plus c, but plus c is 0. So I just have bx, so that's negative 82 over 9 divided by x squared plus 9 dx. Was there any coefficient or constant in front? No. Okay, good. So now we integrate x to get x squared over 2 plus 1 over 9. What happened? Over x, yes. Thank you. That will mess everything up. Yep. Holy nightmare. ln absolute x, and now minus 82 over 9 integral of x over x squared plus 9 dx. How do we solve that? Basic u sub. U equals x squared plus 9. Du equals 2x dx. So plug in a 2 and then do times 2 over here. So the solution is x squared over 2 plus 1 over 9 ln absolute x minus 82 and x and 2 would cancel to 41 over 9. And then over here I have du over u, right? So this is going to be x squared over 2 plus 1 over 9 ln absolute x minus 41 over 9 ln of u, and u is x squared plus 9. No need for absolute values because it's positive. There's a plus c for that final point, and there it is. Yes?
Go back right after we did the long division to like what we got after that. The everything. Could you split that up into 1 over x, whatever, and then make it 9 x squared over all of that thing at that point? So you can eliminate one of the x's with the x out front.
You no, because each one of these terms has to get the full denominator.
No, I know, but can you split it up and then write, you had negative 9x squared over x times.
Yeah, but then you have to do 2 partial fraction decompositions. Because one of your integrals would look like this.
Yeah.
So you just make bigger problem because you have to do 2 independent partial fraction decompositions. There are ways in which you can make it worse, yes. If that's... Let's take a look at the problem that I had no clue what to do, so we'll figure it out.
Hold a little bit so I can see the answer.
Nah, it's a joke of a problem, actually. It's integral of dx over e to the x plus e to the 2x. Yeah, not polynomials. Now what? Hyperbolic something. No.
Have to be x. Dominate for this row, or did I just use x the whole time?
Yeah, use x. So let's try use substitution because obviously it's not going to work, but we'll try. U equal e to dx. What's du? Dx. Great. So if I don't have this e to dx on top, right? How about if I multiply e to dx, e to dx, e to dx, and now get e to dx dx divided by e to the 2x plus e to the 3x becomes du over u squared plus u cubed. And then you do partial fraction decomposition. Isn't it cool?
Very.
What I'm interested in is if the software would be able to solve this. Like if you were to type this integral in, you tried?
Yeah.
Is it working? It's still.
It's using U substitution.
So you factor out u squared and you have u plus 1. There you go. Such an awesome problem. Yes.
It's okay if I felt a different way. It's okay if I. Right.
It's like easy.
Takes out e to the x, and then makes e to the x equals 1, brings e to the negative x up, and then makes it so that I can't see. And then it
We're
ends
on the
up being
same step.
And then it ends up being the same.
Yeah.
And they just did it in a different way.
So now your u's are actually x's. I mean, x's are u's, whatever. You know what I mean. You just go from there. Great, you right? Now you know what's really worth doing? Digging up all of these lectures, right, that I have on the channel, and like, because every single time I do the lecture, I do use different examples. So if you dig up 5 of these streams or 6 of these streams on my channel, every one of them will have 5 or 6 different examples. So you can literally watch, 100 different examples done until it sinks. guys, when the numerator has nothing there, there's 1, right? It's 1. So you see it just says du or it just says dx. It is 1 times dx or 1 times du. And that's where this 1 comes from for the constant term on the bottom. We started with the substitution, right? U equals e to the x, so we have to bring it back. Yes. That's an x there. You just testing you. Yeah, this one is x, yes. Did the computer confirm this or no? Things like push enter now, click. I mean, all it takes is just take a derivative. It's... We're good?
Yes.
Wolfram.
Probably constants and things, yeah. You can reshuffle these things.
There's no negatives. Regular log.
Oh, LOG, that's what they use. Wolfram, yeah, they use LOG instead of, yeah.
Oh, guess the x is
Oh, I get it. Oh, I get it. They use rules of ones and then they combine the two elements together. So it's going to be e over x plus 1. All that over 1 x. So it's going to be 1 plus e.
I've been thinking.
Never good thing.
Yeah, I know you can injure yourself. Like serious issues. What's the integral of secant hyperbolic squared x dx?
Why would you think that? What made
Who
you think
on
that?
Is that what you were thinking?
I've never thought anything remotely close to that.
You're falling asleep and you're like,
Secant hyperbolic squared.
Just, I wonder what I can write down that'll really make them want to not be here.
Go. Which one? Good. That's correct. So it's a basic, right? It's a basic integral. Tangent hyperbolic x plus c. Right? Prove it. Lock the doors. So you see, you can write this beautifully as 2 divided by e to the x plus e to the minus x, everything squared dx. Then you can kick 4 outside and have your dx over e to the x plus e to the minus x, everything squared. And just maybe somewhere in there we can use partial fraction decomposition, right? Because why simple if we can complicate things, right?
Right.
Right. So this is called flexing in mathematics. And, just because, right? Just because you can. Hold on, comrade, I'm in class. Equal tangent hyperbolic x plus c. And, yeah. The message, one of the things is watching
listen to them.
All right, fine. We do this and we'll.
11:30 and you're still here.
11:30, we're still trying. Like, you should make quite a thing, yes. But you saw the trick already, right? You saw the trick. The trick was to, well, now you're going to square this and then do another U sub, call it G sub, and
G sub, then sub.
so when you are looking at this problem, what is the only thing you can do here? Foil it, yes, and cry. So 2 things, right? So we're going to foil, get 4 integral dx over e to the 2x plus Very good. And then plus e to the minus 2x. Good. So now we're going to multiply top and bottom by e to the 2x to kill the negative. Exactly. So that is going to give us 4 integral of e to the 2x divided by e to the 4x plus 2e to the 2x plus 1. And you have your dx. U sub. So u equal e to the x, du equal e to the x dx. So 4 integral. Now on top, you have 1 e to the x as a du, and the other one is u. So u du on top. Are we all bueno with that? You have 2 e to the x's. E to the x times e to the x. One of e to the x's is a u, and the other one is with dx du. So that's that. On the bottom, we have u to the 4th plus 2u squared plus 1.
U equal to e2x, not x.
You want 2x there? Can we do that? If you put a 2 over here, the derivative would be 2.
Yeah.
That's true. It actually helps a lot. Because then I need to plug in a 2 and a half in the front, which changes this to a 2. And then the denominator becomes u squared plus 2. Boss. U squared plus 2u plus 1. Nice. This is 2. And now can we do anything here? This is u plus 1 squared. And then, as I said, g substitution. Oh, we didn't have to use. Oh, that's disappointing. Two integral of dg over g squared. And that becomes negative 2 over g plus c, which becomes negative 2 over u plus 1 plus c, and u was e to the 2x, so negative 2 over e to the 2x plus 1 plus c. Cool. Why, disappointed?
Yes.
I know. Makes us want to do another problem, right? It's like, no, across the board. Well, you have homework to enjoy, so yeah, the whole weekend. And I'm going to put the lab 2, so you guys can enjoy lab 2 over the weekend as well. Yes?
How do you get 10 on 12?
No. Add some constants. Should work out.